Okay. Hey everyone. Thank you for joining me for the 78 meetup, September 24th. It's usually Tuesday. I've been super busy lately. I'll explain you with a few things soon, but I needed to push it to Wednesday. We have 1 hour to have fun with C++ and discuss all kinds of fun stuff. If you are um, if you would like to talk here, have a presentation, anything, let me know. I have a few hours ago, there is a person from Europe that just long story short, we connected on GitHub and uh, he offered to have a presentation. So that might be a bit a different time zone. So a bit different time because he's from Poland. But let's see how it goes. That's for October, so I'm super excited. It's going to be fun because he has a very nice topic to discuss. But yeah, please let me know. Always looking for people to come over. Any length would work. I'm super busy, and it takes some time for me to present for a whole 55 minutes. So that would be good to if someone want to share that time. 1854 kind of stable. Sometimes few people joining, one is leaving, so it depends. JetBrain, thank you JetBrain for sponsoring San Diego C++. JetBrain also provided me Uni to play with. This is their AI assistant, and it's super fun uh, on their Sea Lion platform. They have a very nice new modern UI. I think they call it Islands, which I really like. So, and you know that Sea Lion is free for non-commercial. So it used to be, it used to cost money, and I used to provide you with coupons to purchase that for a year. No, not anymore. So feel free to take a look at that. And Juni is something that they had for some time, and now it's part of Sea Lion as well. So we waited for that to be in Sea Lion, and super excited for that. Yeah, my name is Kobe. I still have books, which I still looking for people if they want to grab from San Diego, where I live. Feel free to do that. This is my agenda. We have one Cppquiz, which is super hard in my opinion, but we'll go over that, and then for the main thing. Before we go there, Packet gave me, I think it was yesterday, discount codes for the CUDA book, so GPU 20, and there's a GitHub Foundation certification guide. Git 20 uh, is their coupon code. If you wanna be on the Discord for all kinds of announcement and similar, I don't know if that, like, this is 2 weeks old, this link, but I can update that if, like, I do update that from time to time. So if it doesn't work, let me know through email, LinkedIn, or anything like that. Okay. Cppquiz. It's fun because you see that. Okay, so this is hard in my opinion, but take a look at that and tell me what do you think would happen here. The C 23 is const, so 0, 1. So we have 6 here. So it's either, so we have 6. Where do you think the ones are? It's super hard, by the way. I couldn't get it right because I didn't know the rules that enough. So it's gonna be hard, but maybe someone is familiar with the rules. I don't have time, so I'm gonna tell you which one. Okay, so this is the one. And the reason is written here that only the second and the last one are basically const, and it's explaining here why For example, this is the last one. Uh, the type of the array is constant, which is const. The entire array type itself is constant. Then the second, for example, the first one, which was surprising, is not const because, and it explained here, this is the type is not considered to be const. Uh, this is const. So this is actually very similar to that guy. So this is 360. Take a look at that and read that. I think it's hard. It wasn't easy, but I wanted to throw that. You don't need to remember or memorize all of that. I didn't. Okay, so usually when I'm done with one session and I don't have any speaker, so I want to have a, a session so we can meet and have 50 minutes just to get some knowledge, more knowledge on C++. I'm thinking about like what is interesting, and sometimes it's just ideas that I'm seeing around me. Sometimes it's something at work, and I decided to gather. I don't know how many. I don't know, like a dozen, maybe 14, 15 types and mechanism in C++ that maybe are not super known. Some of them are actually known, but some of them might not be completely known. And I thought it's going to be fun to just go over them. And by all means, just stop me anytime. Say, okay, hey, I'm using it, or I didn't know that that can work. And I try to have some play with the types, so it's kind of interesting. So there's some types that I actually added some more code, so we can see what can be done with that. And by the way, some of the examples are just for examples. Don't do that. Don't use it at home. Don't like you can use it at home, not in production. Just kind of fun stuff to be aware of. I focused on C++ 17 and beyond, but there are some stuff that were introduced in 11. So yes. So the CPP quiz, Oleg is asking. So if you look to CPP quiz, 360 is the number of the quiz. So each quiz has a number, and just if you go there, you'll see the link. So CPP quiz 360. Okay, let's dive in. Good extent. I'm gonna mute people that I'm not this speaking, and just feel free to mute yourself, to unmute yourself. Stud extent. I don't know how many people know about stud extent. It's part of type traits. It's very handy in generic programming, and it's basically tell you in compile time a specific dimension of your array. For example, I'll give you a few examples. So we have array 1, array 2, 5, which has 5 and 15, and just a scalar. And you can see that this is all in compile time. You can easily know, like you can print, and this is coming from this compile time value. What is the extent? What is dimension for each? So you can see that there is extent of Tickle type array, and then Tickle type array 2, 0 and 1. So we get 5 and 15. And then if it's not an array, you get 0. So 0 means there's no dimension, which is fine. I don't know how many people know about that extent. I'm just curious, because I don't think it's really known enough, unless you're writing a lot of generic programming and you need to know dimension, in compile time dimension of specific array, and sometimes it's help the parameter one. Never seen. Okay, first time. I must say that I've known that. Not like I'm doing C++ for 26 years. I say this is maybe 8-10 years old. Like this, and I think this exists much more than. But just happened. Oh, this is nice. Okay, Valare. Before I go, like who knows about Valare? Valare is actually something which, to be honest, never used it, but it's there, and it's actually very cool if you want to do it. It's kind of vectorized uh, type that you can do a lot of things that you don't need to manually do it, and there's going to be a lot of probably vectorization done here. I'll show you an example. Uh, it's like it's like a vector, but it's not. It's going to lack some of the uh, features that vector has, like for example, pushback. So you don't have pushback. Here's an example. You have two vector like val arrays, integers, and you can do v1 plus v2, and you get this 6, 8, 10, 12 in one shot. So you don't need to do any for loop, which is nice. You want to have v1 times 10, boom, you have 10, 20, 30, 40. You don't need to do any loop. Square root of double, same deal. You have square root of everything. You don't need to do anything. Is that cool? Again, I never used it, like NumPy. Yeah. I bet it's doing vectorization under the hood. So I actually have in my notes to tell you that take this example. I can post the example, by the way. Take this example and run it in Godbolt, that compiler explorer, and see the this is actually my opinion. This is before C++ 11, so this is 9803, if I'm not mistaken. That was, yeah, it's is it 17? I might be wrong. I remember that being before, but I might be wrong. So someone can go and to CPP reference and just type Valare and tell me, and just post in the chat what is the first standard that was introduced. I might be wrong, and it's actually 17, but I just remember it used to be before, but I might be wrong. I don't know if everyone were like all the compiler were basically implementing that, but anyway, yeah, just let me know in the chat. I might be wrong. I thought this is pre-11. Spaceship operator. So spaceship operator, we already had at least one session on that, and maybe I mentioned that from time to time. But this is I noticed that people are not aware of that. People writing in C++20 still writing the special operator, like special comparison operator, manually, while there are some use cases where it's like you don't need to, right? So first thing first, like you don't get, when you, let's say you have a struct with 2 ints or 1, it doesn't really matter, and you want to compare these two. So there are multiple ways to do that. Like there's a, you could do if else, and you have to tie to do that, but you can actually have a comparator operator to overload. Before 20, it was kind of tedious. 20 give you a one shot that you can have a spaceship operator. The thing with spaceship operator is that once you define that, you get all the less than, less equal, and all, and so on. But you need to define either equal default, but you need to define equal and not equal. And you can define not equal with equal, and vice versa. Like you can define one with that, but you don't have that unless you define it. So that's one thing that I needed to memorize. Okay, so you need to memorize that. Sorry about that. So here's an example. So you have point. Point doesn't have, like, if you have 2 points and you want to compare the two, you cannot do that. By the way, I kind of skip strong ordering, weak ordering, and partial ordering. That's like you can read here in the slide, but it's not important right now. But there are multiple categories of ordering that helps. Dominic, my search return to the value is there since, but I didn't. You didn't what? Let me see. Just the standard. Okay. Thank you, Paolo and Dominic. Uh, um, so the category, like the return type, it's not super important right now because it's not a talk about spaceship operator, but it's not. This is not something theoretically uh, uh, needed or something like that. This is actually being used in production. Like we use it in production. Um, so here's the example. We have point. Like if you want to compare the points, either you do it manually or equal default. Boom, you have X and Y in order. If you want equal, you need to define it. It's not defined here because I'm not. Actually, I'm using it here, but it's this is not. This is a typo. It's not synthesized for us. Other stuff are synthesized, but not equal. This needs to be fixed. Um, okay, monostate. So monostate is something that is super useful, but not known enough. So monostate is like nothing or empty, and it's mostly used in variant, but I'll show you like other stuff that can be used with monostate. Just an example, don't use it at home or use it at home, not in production. Uh, let's say that you have a stud variant with monostate in stud string. So you know that when you create a stud variant with, let's say it has multiple types, A, B, C, or whatever, and stud variant can be any. It's like think about like a union, right? And you create the variant. It's gonna hold the first type, so it's not empty. It holds the first type if the type has a default constructed. If the type is default constructor, so there is an empty constructor, like a default, what we call default constructor. If you don't have it, it's not going to compile because unless you provide parameters or arguments to the parameters of the constructor. But if you don't, uh, and you still want to have stud variant with like to define it, but with no state, monostate, have monostate at the first one would create your variant with empty, and then you can put any type, any instance of one of the types that variant was defined with to activate the variant, to actually make it usable for you. So this is the most known usage that I'm familiar with to use monostate in variant, but let's play with it. So I have couple examples to use it in all kinds of other scenarios, just to play around with monostate. Okay, so before that, here's monostate. You have integer and stud string. Technically speaking, monostate here, the reason to have monostate here is just to show you that it's default to nothing. And you can then assign an integer or assign a string and becomes something. And you can put it back to empty. But it's very useful if you have the first type is a type that doesn't have a default constructor and you want to do something like my variant v, then it would not compile, and then monostate kicks in as a solution to put it in like in the first uh, uh, the first index of the monostate. What we say with get 0 means the first one. Okay, let's see how we can create an optional type with unique pointer, monostate, and custom deleter. Again, this is just for illustration to take multiple constructs in C++ and just combine them together. Stud optional is perfectly fine, but this is like stud optional in a very weird way, just to demonstrate something. So we have few things that we're going to introduce. One is we have a stud unique pointer with a file, that's a file handle, and some file deleter that would do close. Then we have a variant that has something which is file pointer, which can be which has the unique pointer and the file deleter, or nothing. So it's like an optional, right? And the monostate here is used just for having nothing, something or nothing. So it's kind of a weird stud optional like type. So let's take a look at how it looks like in code. Again, don't use it in production. You have a file deleter. So just to introduce how deleter are being used. So this is the deleter with file star, and we do fclose. So unique pointer file deleter, and this is the safe file pointer. Then we create a file handle that has nothing or something, and we take this file handle and we stick it in some class, and then we can either in place something, and then from being a file handle that has nothing or something, it has something, but we can also in place the monostate and make it nothing. And the unique pointer is being destroyed, the deleter is being invoked, and so on and so forth. So just an example is to illustrate this funny way, but this is how it's going to look like in like from the user API. And it's all thanks to monostate. So just think about monostate as a way to stick it into variant and use it as something or nothing. There's another niche example that I found when I was kind of investigating like what crazy stuff you can do with monostate. You can actually use it with just unique pointer and a deleter, that the deleter just want to satisfy a pointer to nothing, and monostate is kind of a perfect, I think so. It's a perfect type to use to be used. So this is an example to what we call scoped exit. So if you go to CPP reference and you type stud experimental scoped exit, this is basically what GSL, the guideline support library, GSL or GSL Lite. Finally, it's basically RAII type that you can invoke something, anything, just a lambda, at the end of the scope, any scope. So you define GSL finally or scoped exit and say, oh, when the curly braces, the closing curly braces, like the scope ends, call this function, and you provide the lambda. Now, scoped exit is a bit better than GSL finally because it has a dot release. So think about the use case, and we do have use cases like that in production where you want to run something at the end of the scope. Can be anything, but there is a use case where you say, okay, you know what, I don't want to run that. Something happened, I don't want to run that. So you want to return from the function, return from the scope, exit the scope, and you don't want to run that. So scoped exit has a dot release function that actually provides this important functionality where when the close, when you reach the end of the scope, or you just return from the function, for example, the callback or the function that you passed is not is not there. It's not going to happen. Okay, so Paulo says Dominic is right. Valerie is presented since C++ 98. That's what I remember. I remember that actually it was introduced in C++ 98. Thanks, Paulo. Thanks, Dominic, for confirming that. Okay, let's take a look. So so this is if you have access to GSL, use GSL. If you have access to stud experimental scoped exit, use scoped exit. But this is another RAII that you can use. So think about an exit lambda that has this function. Then you have a unique pointer, monostate. And the reason for monostate is that this is going to be passed here. And probably I need to have here maybe unused just to silence the compiler saying, hey, there is a PTR here that you're not using. And this is just to satisfy the requirement that there is a pointer passed to the deleter. So, and the function is being invoked here, and this is basically a scoped guard. It's not scoped exit with a dot release, but it's a kind of a a quick way to have an RAII. And this is the static monostate, dummy monostate that I'm using here. If you have nothing else, you can use something like that, but hopefully you can use GSL finally, or even better, scoped exit. I actually use scoped exit. I have access to the experimental one, and I'm using it. This should not, like null pointer should not be something that you are unaware of, but I still wanted to have that because I still see null, and like, fortunately not in my team, but in other open source and so on and so forth. Null pointer T is the type. Null pointer is the literal, defined in C stud def. And it's really important because foo null pointer doesn't have ambiguity. Foo zero causes the integer overload. And you basically want to have the null pointer so there is no ambiguity, because foo of null might call foo int with zero. So I'm not gonna delve too much on the details of null pointer. Hopefully you're already using it. It was introduced in Cppquiz 11. We are in 2025. It's been almost 15 years. Let's use it. Okay, the next two types that I would like to present is the integer pointer T and the unsigned of that. You usually want to have unsigned used, and this is basically a type that is wide enough to in your platform to represent or to store a pointer address. And you usually you want to use uint pointer T more than the unsigned, more than the signed one. So the unsigned is good for pointer arithmetic and so on and so forth. You usually you use the signed one if you have like a distance between two pointers, and there might be it might be negative, because the way you subtract one address from another, it might be negative, and then the int pointer T is more handy. But you usually use the uint pointer to have bit mask and proper pointer arithmetic and so on and so forth. So this is like few example of how you're gonna use that cast pointer to uint to perform integer arithmetic. You start getting used to that. That's something that would be more natural in your code. Just remember the uint one is more common than the non-unsigned, like the signed one. Okay, std ignore. Some people doesn't like std ignore because you need to include tuple and like tuple header, and oh, why would I, like tuple header is not tiny. But I personally like std ignore. Right now, that's what we have. You want to silent the compiler if I'm not using something from a return value. But it also used in std_tie when I want to ignore something in when I unpack tuple or pair. Std ignore, in my opinion, is something that is very useful. So let's take a look at an example. Get data returns a tuple of string, integer, and doublet. I just want to have the string and the doublet. I want to ignore the int. So that's one way. There is no way to do it with structure binding. There is a underscore. I don't, like it says here C++20. That's what I remember, but I might be wrong. But underscore is something that can say ignore. But we didn't have it in C++17, which is a bummer. Like std_tie is more powerful here when you want to ignore a specific values in the tuple. I use it a lot if I want to discard value that is returned from a function. Enable search from this. So if you happen to use shared pointer, and shared pointer is something that when you need that, that's cool. But I've seen cases where it was abused and overused. I've like maybe 10 years ago, I've seen a complete system that everything was a shared pointer, like everything. Uh, and the reason was I want to treat this C++ application like a Java that has automatic management of uh, management of memory and garbage collection like behavior, but that doesn't work well, especially with cyclic dependencies, and and basically it feels like abusement of C++, which it's not designed for that. Um, so if you need to return something from your function that is from your class that is a shared pointer, and because it manages a shared pointer, you can't really just return a shared pointer in my class this, because that would create a new shared pointer with a new reference count. So uh, the way you do that is you inherit from stud shared, enable shared from this your class, which basically is a CRTP like pattern. So this is your object, and you want to return your object as a shared pointer, but to continue the reference that is happening right now. And you can see here, let's take a look at the example. So this is the inheritance that I mentioned. I have a shared pointer, so I have 1, so use count would be 1. And then get shared pointer. So I'm getting not a new shared pointer, but I'm getting something that now is giving me 2. And then it's destroyed and all. So that's kind of a very common bug if you don't understand that you cannot just return a shared pointer and hope that it's going to be the same count as the outside observer of your shared pointer. So that's something that you need to be aware of. Okay, so I'm going to introduce 2 things that are part of the stud ranges. And I wasn't aware of that until recently, by the way. This one and the empty view, which is the next one. I don't know how many of you familiar with the dangling and the empty view, which is the next one. But C++ 20 has stud ranges, which is kind of standardized after the ranges v3 library. Stud ranges dangling is actually a nice thing. It's actually a placeholder that says this is it's a dangling, and it's kind of call it the tombstone, because something went out of scope, but you need to return something, and you return this dangling. So this is you can't really use that. And this is really cool, which I wasn't even aware that this exists. So create a vector, create a temporary vector, and at the end of the expression it dies, and you get a result like 3 is there, but you cannot really the reference. Oh, I have the result. So this is like if you have the vector lifetime outliving this whole thing, then yes, you can have it. But otherwise, this prevents you from doing that. And there is a compile time error, which is really cool. So this is something new that I learned. I don't even remember how I found that, but I just found it online when I was reading all kinds of blog posts and similar. Empty view is something again that I wasn't aware of. I am using ranges, kind of a light user of ranges in production. But I never knew about these 2. So empty view, basically empty sequence, and the size would be 0. Instead of returning a null pointer or an empty vector or a pair of AND iterator that would be like begin and end would point at the same thing, you have an empty view, which is, I think, more expressive. So think about something that provides you an empty view or something else. So you have numbers, and in this case, it always provides you an empty view. But think about a function that provides either empty view or none. You can see that, is it an empty view? Yes, true, and the size would be 0. So this is super useful if you want to return something. Like there are multiple ways to tell the user in an API there is nothing. You can use stud optional, there is till expected, there's all kinds of tricks, but empty view is there. I wasn't aware of that when I was like preparing the slides, and this is actually a cool type to use. So if you're using stud ranges or ranges v3, which I believe also would have that, use it. Okay, stud identity. Stud identity is something that I'm usually see that when I'm looking at algorithms that has this projection feature. A projection basically is something that allows me to pick something or to transform something in the context of iterating with algorithm. So let's take a look at an example. So first of all, identity means give me the same value. But before we look at identity, here's a projection. So stud ranges sort. This is why ranges is so fun, because you don't need to have the begin and end. Just give me a something which is I can iterate or over, and then the projection is I wanna sort by the ID. So this is the projection. But sometimes I don't want to do any projection identity or even curly braces. We do that because I think there is a default value here, which is stud identity. This is explicitly saying so that, which basically gives the same value. So it returns the same value, which sounds a bit redundant initially. Like, why do you need identity? You need identity because you need a type or a mechanism that tells you just give me the same thing, while you have a different use cases where it's not the same thing. You do something. So you need the two path. So this is where stud identity is being used. So just remember that this is something that you can and it's being used a lot in algorithms when you need projection, or you want to disable projection and just want to have the same value. Identity is like no op at some point, and no op in C++ is basically semicolon. Obviously, you have no op. You can do no op in many ways. For example, an empty lambda is a no op, and remember that this is actually a very cool, like a dependency injection, if you want to call it like that, where you have a function. Sometimes the function is doing something, and sometimes it's doing nothing. Just remember that an empty lambda is really useful to have. And I'm actually using that in production if I want to have this generic algorithm. But sometimes I do want to pass something that has some functionality, and sometimes I want to have no op. So no op with an empty lambda is actually very useful. So fall through is something that you should be familiar with if using switch case in C++ 17. It's something that allows the reader to be confident that the author of this piece of code knows that, like, they know what they're doing and they didn't miss a break statement. They actually want to have fall through. So this is, and it actually prevents warnings in specific compiler switches. So this is fall through. You don't need to have any comment. This is comment just for us, but it says, okay, 1 and 2 would have the same thing. I didn't forget any break statement. This is intentional. So fall through. There are many attributes. This fall through, I just thought it's very useful, and I don't know how much it's known, but there's a lot of useful attributes, maybe unused, no discard, probably others which I can remember right now, but fall through is one of them. I already mentioned scoped exit. I decided to put that as a separate slide. Scoped exit is an RAII, which is the best thing in C++ with the worst name. Scoped exit, unlike GSL finally or GSLI finally, it has a release API. Like you can say, okay, I don't want that callback function operation to be invoked at the end of the scope. So it's super useful. I'm actually using it because I have uh, kind of latest compilers, usually like GCC 13, and I have access to Stud Experimental. And this is how it's being used. I don't think I have a reset here as an example, but uh, scoped exit, um, see, make scoped exit is just a helper, and I can have here's just it's a printout. It's very useful. I actually, when I was creating the slides, I said, okay, what else from experimental that I remember could I present? Because probably Stud Experimental has tons of stuff. It's like TR, technical, or TS, technical specification or technical review. Things like incubate, like in the incubator that didn't make it yet to the official library. There are two things that I remember. One is propagate const, and one is the observer pointer. But observer pointer, basically, it's the opposite of the GSL owner. And it's just telling you, look, I have this pointer. I'm just observing that. I'm not owning it. And it's very useful for linter, or we use AI coding, um, uh, code review agents. So they review your code, and they would say, you have a pointer here and you're using it, but your destructor is not actually releasing that. And observer pointer actually, this is kind of a no, it's just giving you the same semantic of pointer. It's all in line, so it's kind of removed in maximum optimization, but it tells the compiler and the linter and AI agents that I know that, like, this is by design. I'm not owning. I'm just observing the pointer. So it's very useful. Propagate const. Actually, I have a propagate const example in the next slide. But you know that when you have a const function, this is one of the most confusing things I think in C++. You have a const function. So it's a function that has a const at the end, right? Which means that the data members, when you are in this function, the data members are const, but the const is shallow. So if you have a pointer, it's not what you're pointing to is being const, it's the pointer itself is being const. But sometimes you want to propagate that to even what you're pointing to. Propagate const is doing that, and it's super cool. It's been in experimental for a very long time. It's probably not part of the standard yet. The right code has propagate const. So let's take a look at the left first. I have a class that has a function named modify. It's just printing, but it's not const. Okay, I have a const type, and I'm creating the instance, and I'm invoking a function. The function is const, so it means that, for example, the unique pointer is const, but I can actually call widget pointer modify. And this is usually confusing people. Like, this function is const. I can call a non-const function on my widget. So if you think about it, this is confusing. Let's switch to the propagate const. So propagate const means actually it goes deeper, and this would not compile because now it returns const my widget, and now if I want to call modify must be const. Super useful. Okay, now I'm thinking that I needed to probably have reference swapper as another. It's not experimental, but reference swapper is something that not a lot of people familiar with, but it's super useful. Bitcast. So this is another useful thing in C++20, and it's better than reinterpret cast. It's doing the right thing, especially for trivially copyable. It's safer. more predictable. It's context were friendly, and it's better than reinterpret cast in some cases. Let's take a look at a very classic example. You have a float, and I don't want to take the float and just cast it to an integer. Like I don't want to have 3.14 and get the 3. I actually want the same bit representation from the float to the integer and maybe do something with it, maybe put it back as a float. But I want to do it in a predictable way. I don't want to invoke undefined behavior. So, and by the way, take a look at std bit cast implementation in your IDE. It's not that complicated, and it's doing memcopy. If and the memcopy is optimized away, so that compiler is aware of what you're trying to do. But we're trying to do something with a it's not undefined behavior. So bitcast would give me u, which has the same bit representation as the float. Now they are the same size. It's 4 bytes and 4 bytes on most machines. My machine. Now I can take u and bitcast it back. This actually needs to be this u needs to be it's fine. It's all fine. I was confused for a second. So u is an integer, and I'm bitcast it back to a float, and it's all good without any undefined behavior. So bitcast is your friend. I'm using it in production. Big saver. In our case, we turn on almost every clunk tidy that is known to humanity in our build system. So we have everything that you can think of. This is something that we discussed last time, so I'm going to make it very fast because it's already in the previous session. But I still wanted to have that as part of the slide deck. So if someone is going over the slide deck, the prev, next, and events are maybe underutilized, but they are very useful if you want to do pointer manipulation and you don't want to do any plus and so on and so forth. Next and prev return something. Advanced is actually modifying the original iterator. That's basically it. Backward so n can be negative in this case, and prev and next just moving to either direction. Iterator category requirements is on the last column. Just remember that. And I have some examples. We already discussed that last time, so I want to skip that. So that's basically my last slide. Hopefully, you learn at least 1 or 2 new things in C++. We talked about all kinds of features, spaceship, fall through, model state, ignore, shed from this, bitcast, scoped exit, finally, what else? Ignore, we said already. So all kinds of things that are useful. Some are more useful, some are less, but still useful to know, at least, that you have this toolbox. Just like any language, Python or anything else, you have this toolbox. You want to know when to, what kind of tools are suitable for your specific use case. So hopefully this, the last 50 minutes gave you some taste of that. Do you have any questions? Thank you, Oleg. The slides are always uploaded to Dropbox. Like a directory that should be shared. If you cannot find it, always let me know. You can find me either in Meetup, if you have the access to the Discord, or LinkedIn. If you have my email, also you can shoot me an email. As I mentioned, next month I'm planning to have a speaker from Poland. He owns a specific repo, which is super interesting. So I'm super excited to have him soon. Yeah, that's it. That's what I had for today. If no further questions, we can go back to our afternoon. Thank you.
Thank you. Bye.
Thanks. Take care.